Hello guys, I am Vaishali Kikan and we are discussing chemistry. Today we are going to start a new chapter, the quantities in chemical formulas. We are going to discuss a lot of concepts and numerical problems on this. So let's start our discussion with the entity. What is entity? Entity is denoted as the particles of the matter, right? How many particles of the matter we have? It is called as the entity. It could be atoms, it could be molecules, or it could be ions. So atom, molecules or ions are all entities. Now entities are making up the matter. So matter is composed of atoms, or matter is composed of molecules or of ions. Now coming to the mole. What is the mole? Mole is the unit of amount. How much amount we have? We have the unit that is mole. Right, to calculate the amount we have the unit mole. The amount of a substance containing 6.02 into 10 raised to power 23 entities is 1 mole. Right, so here if I have 6.02 into 10 raised to power 23 atoms, ions or molecules, it is composing 1 mole. So we are calculating actually the amount of the substance. Right, so now we have a constant which is called as the Avogadro's constant, which is denoted by Na. Right, so Avogadro constant is denoted as Na. What is Avogadro constant? It is the number of entities in 1 mole of substance. So here we had taken 6.02 into 10 raised to power 23 entities. So these number of entities which are present in 1 mole, it is called as the Avogadro constant. So Avogadro constant would be equal to 6.02 into 10 raised to power 23, because these many entities are present in 1 mole of a substance. Coming to the sample problem 1, which states calculate the product of 2 into 10 raised to power 5 and 7 into 10 raised to power minus 8. So when I multiply these two in the scientific notation, what I am going to do? I am going to multiply the coefficients 2 and 7. So 7 multiplied with 2 is giving me 14, and we have to now add the power of 10. So because we have multiplication, we will add the powers. So 10 here we have the power 5, 10 here we have the power minus 8. So 14 into 10 raised to power 5 plus minus 8. Why 14? 2 into 7 is 14. So it can be represented as 5 minus 8. 5 minus 8 is 5 plus minus 8 is 5 minus 8, which is minus 3. So 14 into 10 raised to power minus 3, which is not a scientific notation. In the scientific notation, we have to represent it like this. So 1 decimal 4 multiplied with 10 raised to power minus 2, which is the scientific notation. In the scientific notation, we have to take the decimal after the first digit. Now coming to the next question, which states divide 9 into 10 raised to power 4 by 3 into 10 raised to power minus 6. So when I divide these two, again I have to do the same thing. I have to divide the coefficients first, and then in the power of the 10, we have to subtract the power. So 10's power would be subtracted. So 9 divided by 3 is 3. So 10 raised to power 4 minus 10 raised to power minus 6 we have. So 3 into 10 raised to power 4 minus 6. Now 4 minus 6 would be 4 plus 6, which is 10. So 3 into 10 raised to power 10 is the answer. Now coming to the molar mass. What is the molar mass now? Molar mass is the mass of 1 mole of a substance. As the name suggests, it is the mass of 1 mole. That is molar mass. So in the 1 mole, how many entities we had? We had 6.02 into 10 raised to power 23 entities. So I can say molar mass is the mass of 6.02 into 10 raised to power 23 entities. How we are going to represent the molar mass? With the help of capital M. So the unit of molar mass is gram per mole. So each and every of the molar mass has a standard unit, gram per mole. Like if I have the molar mass of neon because it is having only 1 atom, right? So here we will be having 1 into 20.18 gram per mole, which is 20.18 gram per mole. So neon has the molar mass 20.18 gram per mole. In the oxygen molecule, we have 2 oxygen atoms. So 2 into the molar mass of one oxygen atom would be the molar mass of O2, right? So 2 into molar mass of oxygen atom is 16.0, so 2 into 16 would be 32.00 gram per mole. Now coming to the molar mass of P4, that is the phosphorus. Phosphorus is occurring as the molecule P4. So here we will be having 4 atoms of phosphorus. So here we will be having 4 multiplied with the molar mass of one atom of phosphorus to calculate the molar mass of phosphorus molecule. So one atom of phosphorus has the molar mass 30.97, which I can say 6.02 into 10 raised to power 23 atoms of phosphorus are having the molar mass 30.97. Now we are calculating the molar mass of 6.02 into 10 raised to power 23 molecules of P4. Right, so it would be 4 into 30.97, which is the molar mass of one phosphorus atom, which is equal to 123.9 gram per mole. Now coming to the next concept, which is the numerical equivalency of atomic and the molar mass, right? How they are equivalent. Mass of 1 mole of element in gram per mole has same numerical value as average atomic mass of the element in AMU. Atomic mass unit, if I see the mass of 1 mole of element, if I see the carbon atom, so we are going to understand this statement with the help of carbon atom. One carbon atom has the atomic mass in gram per mole, right, which is 12.01, right? In AMU also it is 12.01. We have to now start from AMU and we have to derive that 12.01 AMU is equal to 12.01 gram per mole. So one carbon atom will be having the atomic mass 12.01 U, right? So, and I know 1 U is having 1.661 into 10 raised to power 24 gram. One atomic mass unit has the mass in gram equal to 1.661 into 10 raised to power minus 24 gram. Now what is the AMU of carbon? 12.01. So we are going to multiply it with 1 U to get the mass of the carbon in gram. So here 12.01 U multiplied with 1.661 into 10 raised to power minus 24 gram upon 1 U. So this U and U is going to cancel out right here. This U is going to cancel out and I am going to get the mass of the carbons 1 mole in gram. So it is 1.99486 into 10 raised to power minus 23. Right, now we have to find out this mass in gram per mole. So in 1 mole, so this is the mass of the carbon atom for 1 carbon atom. Right, now we are going to find out the mass of the carbon atom for 1 mole. For 1 mole, I have how many carbon atoms? I have 6.02 into 10 raised to power 23 entities in 1 mole. So I am going to multiply the mass of 1 atom with the number of entities in 1 mole. So 1.99486 into 10 raised to power minus 23 multiplied with the Avogadro number, which is 6.022 into 10 raised to power 23. It is giving me 12.01 again. So you can see AMU will be equal to 1 gram per mole, right? So whenever I have the 12.01 AMU, it will be equal to 12.01 gram per mole, right? Now I can again read the statement and you can understand it. Mass of 1 mole of element in gram per mole has same numerical value as the average atomic mass of the element in atomic mass unit, right? We started from U and we derived how it is equal to gram per mole. Now coming to the molar mass of compounds. Now we can find out the molar mass of the compounds as well. We have found out the molar mass of the element, right? We have found out the molar mass of the molecules, and now coming to the compound. In the compound we will be having some different atoms. Like if I talk about hydrogen phosphate, we have H3PO4. So we have 3 atoms of hydrogen, 1 atom of phosphorus and 4 atoms of oxygen in 1 molecule of hydrogen phosphate. So now coming to the molar mass will be equal to 3 into the molar mass of hydrogen plus 1 1 into molar mass of phosphorus plus 4 into molar mass of oxygen, which is 3 into 1.01, which is the molar mass of hydrogen, plus 30.97, which is the molar mass of phosphorus, plus 4 into 16.00, which is molar mass of oxygen. So it is equal to 98.00 gram per mole. Similarly, we have sodium chloride. Sodium chloride is now an ionic compound. It is composed of ions of sodium and chloride. So it will be equal to the molar mass of sodium ion plus the molar mass of chloride ion. So molar mass of sodium will be approximately equal to the molar mass of sodium ion, and sodium ion will be equal to molar mass of sodium. Right, so molar mass of sodium ion is approximately equal to the molar mass of sodium, so we can take it equal to 22.99 for the sodium ion. For the chloride ion also it is equal to the molar mass of chloride, so chlorine atom, so it will be equal to 35.45. because here we have removed an electron will be having negligible mass. Here we have added an electron which is having the negligible mass. We can now approximate equal to the molar mass of sodium and molar mass of chlorine atom. So we can add these two and we can get the molar mass of sodium chloride compound as 58.44 gram per mole. Similarly, we have sodium sulfate. Sodium sulfate will be having Na2SO4, so it will be equal to 2 into mass of sodium ion plus mass of sulfate ion. Now mass of sulfate ion will be having the mass of sulfur plus 4 times mass of oxygen. It is added with twice of mass of sodium ion. So twice into mass of sodium ion is 22.99 plus mass of sulfur, which is 32.07, plus 4 into mass of oxygen, which is 4 into 16.00. It is equal to 142.05 gram per mole. So this is the molar mass of the compound of sodium sulfate. Coming to the calcium chloride dihydrate, first of all we are going to see its formula. It's CaCl2.2H2O. So here we have the calcium ion. So molar mass of calcium, 2 positive ion is added with the twice of the molar mass of chloride ion, which is added with the twice of the molar mass of H2, because we have two molecules of H2O, so twice of the molar mass of H2. How we can write it? Molar mass of Ca2 positive plus 2 molar mass of Cl negative plus 2 into H2O is composed of 2 molar mass of hydrogen plus molar mass of oxygen. So we can write it, molar mass of Ca2 positive is 40.08 twice into molar mass of chloride ion, which is 2 into 35.45, plus we have 2 into 2 molar mass of hydrogen, so which is 4 into molar mass of hydrogen, which is 1.01, plus 2 into molar mass of oxygen, which is 2 into 16, so 147.02 gram per mole. We have some questions also based upon this. First question is, calculate the molar mass of carbon dioxide. We know carbon dioxide is composed of carbon and oxygen, so molar mass capital M of CO2 we have to calculate. We know the molar mass of carbon is 12.01 gram per mole, molar mass of oxygen is 16 gram per mole. Molar mass of CO2 will be equal to molar mass of carbon plus twice of the molar mass of oxygen. So 12.01 plus twice into 16 gram per mole, which is 44.01 gram per mole. Similarly, we have the question number 2, which states, calculate molar mass of iron 3 chloride. Now iron 3 chloride is Fe2O3. We have to calculate the molar mass of Fe2O3. We know the molar mass of iron is 55.85 gram per mole and the molar mass of oxygen is 16 gram per mole. The molar mass of Fe2O3 will be equal to twice of the molar mass of iron plus thrice of the molar mass of oxygen. So 2 into 55.85 plus 3 into 16, which is 159.7 gram per mole. Calculate the molar mass of iron 3 chloride hexahydrate. Right, so here we have hexahydrate also. So this is the next question based upon the similar concept. So we have to calculate the molar mass of FeCl3.6H2O. Now iron 3 chloride hexahydrate is FeCl3.6H2O. We have to calculate its molar mass. We know the molar mass of iron to be equal to 55.85 gram per mole, molar mass of chlorine to be 35.45 gram per mole, molar mass of hydrogen to be equal to 1.01 gram per mole, and molar mass of oxygen is 16 gram per mole. So molar mass of FeCl3.6H2O will be equal to molar mass of Fe3 positive plus thrice of the molar mass of Cl negative plus 6 times molar mass, twice into molar mass of hydrogen plus molar mass of oxygen. So 55.85 plus 3 into 35.45 plus, here we have 6 into 2 molar mass of hydrogen, which can be equal to twice 12 into molar mass of hydrogen. So 12 into 1.01, here we have 6 molar mass of oxygen, so 6 into 16. So when you calculate it, it will be equal to 270.32 gram per mole. Right, I hope you understood till now. Coming to the calculations involving the molar mass. Now we can have the various calculation like converting the mass into amount or converting the amount into the mass, right? So when I have the amount is represented in the number of moles, right? Amount is represented in the number of moles, which is represented as small n. It is converted into mass, which is represented as small m. So when I have the amount, it can be converted into mass, and when I have the mass, it can be converted into amount, right? So now when I have the mass can be converted into amount as n is equal to given mass upon the molar mass, right? Capital M is the molar mass. So with the help of the given mass and molar mass, you can find out the amount, which is the number of moles, right? When the number of moles are given, you can find out the given mass by multiplying it with the molar mass. So n multiplied with capital M is the given mass. We have some questions also based upon it. Now coming to the conversion of mass to amount, right? So if I have the, we have the NaOH, right? So NaOH's given mass is 4 gram, right? So we can calculate the molar mass of NaOH with the help of similar method that we have discussed till now, right? So given mass is 4 gram, molar mass of NaOH is 40 gram, right? So what I can do, I can now find out the number of moles. Number of moles is the given mass divided by molar mass. Given mass is 4 gram, molar mass we know is 40 grams, so the number of moles or the number of amount is 0.100 mole. Right, similarly we can convert the amount also to the mass, right? So if I am given 1.5 moles of NaOH, right, the number of moles are given, what I have to do, I have to multiply the number of moles with the molar mass to calculate the given mass, right? So number of moles is 1.5, I can multiply it with the molar mass of NaOH is 40 gram. So when I multiplied 1.5 with 40, I am going to get 60 gram, which is the given mass for 1.5 moles of NaOH. So now coming to the question number 1, which states, according to a manufacturer, a typical can of cola contains 40 gram of sucrose, and now the formula of sucrose is also given, C12H22O11. Now we have to calculate the amount of sucrose in 40 gram of cola, right? So now first of all we have to calculate the molar mass. The formula is given, we know molar mass of carbon atom, which is 12.01, molar mass of hydrogen we know it is 1.01, and molar mass of oxygen we know it's 16. So the molar mass of the given compound C12H22O11, which is sucrose, will be equal to 12 into the molar mass of carbon plus 22 into the molar mass of hydrogen plus 11 into the molar mass of oxygen. So 12 into the molar mass of carbon is 12.01 plus 22 into the molar mass of hydrogen, which is 1.01, plus 11 to the molar mass of oxygen, which is 16. So when you add it, you will be getting 342.34 gram per mole. This is my molar mass of sucrose or C12H22O11. Right, now we have the conversion factor as 1 mole divided by 342.34, or you can remember the formula, N is equal to given mass upon molar mass. What is the given mass? Given mass is 40 gram. Molar mass we have calculated, so number of moles will be equal to given mass 40 divided by 342.34, which is 0.117 moles. So this is how you can calculate the amount in moles. Now coming to the next question, which states, a liter of human blood typically contains 4 millimole of glucose C6H12O6. So glucose formula is also given, C6H12O6. Calculate the mass of this amount of glucose. We have to calculate the mass. Which formula you are going to use? This formula you are going to use. Now the molar mass we can calculate because the formula is given C6H12O6. Molar mass would be 6 times the molar mass of carbon plus 12 times the molar mass of hydrogen atom plus 6 times the molar mass of oxygen atom. So 6 into 12.01, which is the molar mass of carbon, plus 12 into 1.01, which is the molar mass of hydrogen, plus 6 into 16, which is the molar mass of oxygen, gram per mole. So when you calculate it, it will be equal to 180.18 gram per mole. In the question, the number of moles are also given. The number of moles is 4 millimole. So millimole will be equal to 10 raised to power minus 3 moles. So the number of moles is 4 into 10 raised to power minus 3 moles. Now we can find out the given mass. Given mass is the number of moles multiplied with the molar mass. Number of moles is given 4 into 10 raised to power minus 3 moles. Molar mass we had calculated 180.18 gram per mole. So the given mass of the glucose in human blood is 0.72, right? So now coming to the determination of the number of entities. We have now calculated the number of moles and the mass. Now we are moving towards the number of entities. Here the Avogadro's constant will be playing in the picture. Now we have the amount. Amount is present in the mole, right? So when I have the amount and I have to find out the number of entities, what I am going to do? I am going to multiply with the factor 6.02 into 10 raised to power 23. So if I have the given number of moles as n, if I multiply it with the Avogadro's constant 6.02 into 10 raised to power 23, I will be getting the number of entities capital N. If I am given the number of entities capital N, and if I want to find out the number of moles, what I am going to do? I am going to divide by 6.02 into 10 raised to power 23. So this is how we can interconvert in between the number of moles and the number of entities. So based upon this also we have the questions. First question is calculate the number of atoms in 1 kilogram bar of gold, right? Now here again we have to calculate the number of entities and the amount, the mass of the gold bar is given. We know the molar mass of the gold as well. So gold is represented as Au. The molar mass of Au is 196.97 gram per mole. Right, so we will be finding out the number of moles of Au. Number of moles will be equal to given mass upon molar mass. Given mass is 1 kg. 1 kg will be equal to 1 kg is equal to 1 into 10 raised to power 3 gram is equal to 1 kilogram. Right, so all of the calculations we have to do in grams. So we have to first convert the kg into grams. So we have the given mass as 1 into 10 raised to power 3 gram divided by the molar mass. Molar mass of Au is 196.97. So when you divide 1 into 10 raised to power 3 by 196.97, you are going to get the number of moles, which is 5.0760 moles. Now I know the number of moles, and when I multiply the number of moles with the Avogadro constant, I will be getting the number of entities. So what is the entity over here? Entity is atoms. So the number of atoms of gold will be equal to number of moles, which is 5.0760 multiplied with the Avogadro constant, which is 6.02 into 10 raised to power 23, which is equal to 3.056 into 10 raised to power 24 atom. We can now round it off also. We can write it as equal to 3.06 into 10 raised to power 24 atoms. So 1 kg bar of gold will be having 3.06 into 10 raised to power 24 atoms. Now coming to the next question, which states ammonia is a pungent gas released from smelling salts. Calculate the number of molecules in a 4 milligram sample of ammonia. Right, so the given mass of ammonia is given, right? We know the ammonia is having the formula, which is NH3. So molar mass of NH3 we can find out. We know the molar mass of nitrogen, which is 14.01. We know the molar mass of hydrogen, which is 1.01. So molar mass of NH3 will be equal to molar mass of nitrogen 14.01 plus thrice into molar mass of hydrogen, which is 3 into 1.01, which is equal to 17.04. Given mass of NH3 is 4 milligram. So 4 into 10 raised to power minus 3 gram. 1 milligram will be equal to 10 raised to power minus 3 gram. So here we have 4 milligrams, so 4 into 10 raised to power minus 3 gram. Now we can find out the number of moles. Number of moles will be given mass upon the molar mass. Given mass is 4 into 10 raised to power minus 3. Molar mass we have calculated 17.04, so it will be equal to 2.347 into 10 raised to power minus 4 mole. Right, so if I know the number of moles, I can find out the number of entities. How? By multiplying with the Avogadro constant. So what is the number of moles? 2.3474 into 10 raised to power minus 4 multiplied with the Avogadro's number 6.02 into 10 raised to power 23, I will be getting the number of molecules, which is 1.41 into 10 raised to power 20 molecules. Right, coming to the next concept, which states determining the number of entities in a compound. Right, so when I have a compound, I can find out the number of entities also in the compound when I know the number of moles. Right, so let's talk about the compound of aluminium sulfate, where we have one formula unit. So in one formula unit we have the Al3 positive ions equal to 2, right, which is the cation. Cation is my Al3 positive, so we have 1 into 2, that is 2 Al3 positive ions. The number of sulfate ions will be equal to 1 into 3, which is 3, right. Sulfate ions are my anion. In one formula unit we have 2 aluminium ion and 3 sulfate ion. When I have 10 formula unit, I have 10 into 2, which is 20 aluminium ions, and 10 into 3, which is 30 sulfate ions. So 20 cations and 30 anions when I have 10 formula unit. When I have 20 lakh formula unit, so that time I will be having 20 lakh into 2, that is 40 lakh aluminium ions, that is cations, and 20 lakh into 3, that is 60 lakh sulfate ions, which is the anion. Now if I talk about 1 mole, in 1 mole I will be having 6.02 into 10 raised to power 23 entities that we know, right. So now here if I talk about the 2 mole Al3 positive, in the 2 mole of aluminium 3 positive, I will be having, if I have 1 mole of formula unit, in the 1 mole of formula unit we have 2 mole of Al3 positive, right. So 2 mole of Al3 positive, which means 2 into 6.02 into 10 raised to power 23, which is 1.204 into 10 raised to power 24 aluminium ions, because aluminium ion are twice of the number of formula units. If I have 6.02 into 10 raised to power 23 entities of formula unit of compound, I will be having twice the entities of aluminium ion. I will be having thrice the entities of sulfate ion, so 3 moles of SO42 negative, which will be equal to 3 sulfate ions divided by 1 formula unit multiplied with 6.02 into 10 raised to power 23 formula unit, which is equal to 1.806 into 10 raised to power 24 sulfate ions, right. If I have any compound, I can find out the number of entities also, the number of cations, the number of anions also. So based upon this we have a question. Benzaldehyde C6H5CHO is a compound used to give prepared food an almond flavor. Find the number of carbon, hydrogen and oxygen atoms in a 26.5 gram sample of benzaldehyde. Given mass is 26.5 gram. We can find out the molar mass. So you can see here in the benzaldehyde we have 7 carbon atoms, 6 hydrogen atom and 1 oxygen atom. So we can find out the molar mass of benzaldehyde as well, which is 7 into the molar mass of carbon atom, which is 12.01, plus 6 into the molar mass of hydrogen atom, which is 1.01, plus the molar mass of oxygen atom, which is 16.00 gram per mole. So when you add it, you will be getting 106.13 gram per mole. Now this is the molar mass of benzaldehyde C6H5CHO, which is 106.13 gram per mole. Now from the molar mass and the given mass, I can find out the number of moles. Number of moles is given mass upon molar mass. Given mass is 26.5 gram divided by the molar mass, which is 106.13. You are going to get the number of moles as 0.24969 moles, right? So when you get the number of moles, you can find out the number of entities. What is the number of entities? Number of benzaldehydes that we have. The number of benzaldehyde would be equal to number of C6H5CHO, which is equal to the number of moles that we have found out multiplied with the Avogadro constant. So given number of moles that we have calculated multiplied by 6.02 into 10 raised to power 23. So 0.24969 multiplied with 6.02 into 10 raised to power 23, I will be getting 1.503 into 10 raised to power 23 molecules. Now this is the number of molecules of benzaldehyde. I have to calculate the number of molecules of carbon atom. The number of molecules of carbon atom in the one molecule of benzaldehyde is 7. So what I am going to do, I am going to multiply the number of benzaldehyde entities by 7 to get the number of carbon atoms, right, in this benzaldehyde. So number of carbon atom will be equal to 1.503 into 10 raised to power 23 into 7, which is 10.522 into 10 raised to power 23 atoms. Similarly, the number of hydrogen atom will be equal to 6 times the number of benzaldehyde atoms, right? So we will be having the number of molecules of benzaldehyde as 1.503 into 10 raised to power 23, which is multiplied by 6 to get the number of hydrogen atom, which is 9.02 into 10 raised to power 23 atom. In one benzaldehyde molecule, I have only one oxygen atom, so the number of oxygen atoms in 1.503 into 10 raised to power 23 benzaldehyde molecule will be equal to same 1.503 into 10 raised to power 23 atoms of oxygen, right? So in this manner, I hope you understood all of the questions and all of the concepts. So let's meet soon in the next class where we will discuss the next topics of this chapter. Thank you so much.